everyone. Today we have a special guest, Dr. Robert Lefkowitz. He is an American physician. He is best known for the groundbreaking discoveries that reveal the inner workings of an important family of G protein-coupled receptors, for which he was awarded the 2012 Nobel Prize for Chemistry. He is currently an investigator with the Howard Hughes Medical Institute, as well as a James B. Duke Professor of Medicine and Professor of Biochemistry and Chemistry at Duke University. Sir, how are you doing today?
I'm doing just fine, thanks. Nice to be with all of you.
Thanks, sir. Sir, we would like to ask you some questions about your scientific research about in biochemistry and something that how were you inspired, who inspired you in biochemistry like thing. So we start.
Good.
So the first question is, when growing up, what attracted you to the field of biochemistry?
Well, growing up, I was very interested in biochemistry, but not interested enough to actually think I would ever enter the field. My primary interest was in clinical medicine. My inspiration was my family physician, who made house calls in the Bronx, New York City. And I just really fell in love with what he was doing, so that by about age 8 or 9, I had little doubt that I would become a physician like him. He seemed to know all this great scientific stuff that other people didn't know, and he could somehow leverage that information to make you feel better. He carried this black bag out of which he could produce all manner of magical instruments, a stethoscope, a reflex hammer, an otoscope, and a ophthalmoscope, his prescription pad. I was just absolutely taken with the whole thing. So I went to a special public high school in the Bronx called the Bronx High School of Science for gifted and talented people, students who were interested in science, medicine, and the like. Then to Columbia College as a chemistry major, where I never did any research, original research. I just took courses, and there was a particular professor there, a young professor of biochemistry named Ronald Breslow, went on to a very distinguished career, and he single-handedly gave a seminar in biochemistry, which I took as a senior, and that further turned on my interest in biochemistry. Again, never dreaming that I would ever do research. I only wanted to be a practicing physician. I went to the Columbia University College of Physicians and Surgeons and graduated there in 1966 and did 2 years of house staff training as an intern resident in medicine. I would have happily gone on to finish my clinical training and practice medicine for the rest of my life, but the Vietnam War was raging in the late 60s, and all physicians were drafted upon graduation from medical school. And you were given a 2-year deferment, and then you joined either the Army, the Air Force, the Navy, or the Public Health Service. And you spent one of your 2-year hitch in Vietnam. The only exception was if you were fortunate enough to get a commission in the Public Health Service, which had certain assigned positions in the United States, especially at some of their research installations like the CDC and the NIH and the that we hear so much about these days. I was fortunate enough, I guess because of high grades and high academic standing and recommendations, that I was able to get the commission in the Public Health Service and be assigned to the NIH for 2 years, from 68 to 70, and I learned how to do research there. So that was when I first was exposed to research, and it did not go well initially. For the first year or year and a half, just about everything I touched seemed to fail. I made no progress. This was the first time in my life, career, that I had ever met with any sort of protracted failure in anything I had endeavored to do. And it was humbling and discouraging. I think as I look back on it, I was probably mildly clinically depressed during that time. But fortunately for me, during the final 6 months there, my projects began to work. I made some headway. I published my first few scientific papers and got a little bit of a taste of what success in science is like. Nonetheless, I left to go to Boston to finish my clinical training, and while there, realized I actually missed the laboratory. So after 6 months of intense clinical work at the Massachusetts General Hospital, which is one of the main teaching hospitals of Harvard, I realized that there was just something missing, and I eventually came to the correct conclusion, as it was, that what I was missing was the day-to-day excitement and challenge of being in the laboratory. And so I sought out another mentor there and began doing research again, together with my clinical work for the next 2.5 years. And then I came to Duke in 1973, spent the first couple of years splitting my time between doing clinical teaching and establishing my laboratory program. But very quickly, as we began to make one discovery after another, it became clear to me that I was going to have to cut back on my clinical work, which I did. And so whereas the first year or two I was here, I probably spent 60% of time in the lab and 40% on the wards and the clinics. Within a few years, I was probably doing 80% of my time in the laboratory and 20% doing clinical teaching. And as they say, the rest is history. So that's pretty much how the whole thing evolved.
Yes, sir, that's a truly inspiring journey of yours. So the next question will be asked by Lucas. Lucas, I hand over the mic to you.
Okay. So I wanted to know, what is the most significant outcome of your research, and how does biomedical research impact science and society?
So as for the impact of the work, that's an interesting question. I think it's clear that the major impact of the work has to do with the development of new drugs. So my work was always on receptors for hormones and drugs. So receptors are molecules on the outside of cells with which drugs and hormones and neurotransmitters initially interact with great specificity, much like a key fits into the lock. You have to have exactly the right complementarity and structure for that to happen. So in that analogy, a drug or a hormone is the key and the receptor is the lock. Now, when I started my research 50 some odd years ago, there was no general agreement there was even such a thing as a receptor. And in the early years of my career, what I set out to do was to establish methods which would allow us to find out if there was such a thing as a receptor. And we were successful at that. It took many years. And then we learned all about the receptors and what they do and what their structure is, how they're regulated. The work was always driven primarily just by raw curiosity and a desire to understand, not by any specific intention to develop drugs or cure a disease. Nonetheless, over the years, the discoveries that we made were leveraged by many laboratories and drug companies and biotechs to create drugs based on our work. And the receptor family that we discovered is referred to as G-protein coupled receptors, or GPCRs. Today, this family of receptors, and believe it or not, there are almost 1,000 of them. They regulate virtually all known physiological processes in humans. And in addition to hormones and drugs, these receptors mediate our senses of vision through a protein called rhodopsin in the retina, and also our sense of smell, several modalities of our senses of taste. So they do all sorts of things, and there are anywhere from 800 to 1,000 different kinds of these G-protein coupled receptors. Well, today, the G-protein coupled receptors are by far the largest class of drug targets. And in fact, they say that about a third of all FDA-approved drugs in this country are drugs which target the receptors in the family that we discovered, and that's actually 700 drugs. So by far, that is the major, I guess, impact of our work. on society. Now, if you say in general, what is the impact or importance of science and society? Well, there couldn't be a more timely question. I mean, we need to look no further than COVID-19. Where would we be were it not for the remarkable mRNA technologies that were developed a few years back and which stood ready to be immediately utilized to develop these vaccines at a rate that I don't think any of us could have dreamed of. And also to begin to come up with therapies, right? I mean, some of the monoclonal antibodies that are being used. I am not, by the way, speaking of ivermectin or hydroxychloroquine, which are nonsense. But yeah, so I think that protecting the health of the public and finding cures for diseases is, to me, the major impact and import of biomedical research.
That's wonderful to hear. So I'd like to ask a follow-up to the previous question. So what sort of advancement do you see in your field, specifically that of the G protein coupled receptors, in the next few years or decade?
So I think that drug development is always the search for more and more specific drugs which have fewer and fewer side effects. Now, the term side effect is almost a misnomer because any biologically active molecule, like a receptor, does certain things. Usually, most proteins do a variety of things. When you target such a protein, like a receptor or an enzyme or many other things, when you target it, you do that specifically because you know that one of the things that you can either stimulate through that receptor or block through that receptor, that if you could do that, it would have a salutary effect on a disease or a symptom of a disease. But most of the time, there are other things that that molecule does that, frankly, you don't want to do, okay? And when those effects are stimulated or blocked, we call them side effects. But they're not really, if you think of it, what I'm trying to say, they're not really side effects. They're every bit as much a physiological effect of targeting that biologically active molecule as the effect you want. So the question is, how can we get more and more specific drugs, which are therefore going to be more and more effective? And I think that's has been and continues to be the big challenge. And that's where some of the work that we've done in recent years comes in. In the early days, I'm going back 40 years or so, we found that there were many more what we call subtypes of receptor for molecules, very closely related receptors. For example, let's take adrenaline, okay? At the time that I started doing my work, people thought there might be two different receptors for adrenaline. But by the time, we were calling them alpha and beta, but by the time we got done with our biochemical and molecular cloning experiments, we knew that there were 9. In the case of serotonin, it was thought that there were 1 or 2 serotonin receptors. There turned out to be 15. Now, each of these has a specific portfolio of things that it does. So as drug development advanced, you could begin to target drugs at specific subtypes of receptors. And rather than stimulating, say, every serotonin receptor, which, for example, would happen when serotonin was administered, you could target a much more selective subset of things, get a more selective effect, and fewer side effects. Then, I guess about 15 years ago, we discovered that even for a single receptor, it could signal through different signaling pathways. One set of pathways, what we call the canonical ones, are through proteins called G proteins, hence the name G protein coupled receptors, because all the receptors in this family work by stimulating another class of protein called G proteins. But we had discovered a molecule, which we called beta-arrestin. There are two different isoforms of that also interact with the receptors when they're stimulated. We had actually discovered the beta-arrestins, and they were named arrestin because they actually turn off signaling through G proteins. They bind to the activated receptor, and they block its ability to interact with the G protein. We call this process desensitization. That means as you're continuing to stimulate a receptor, instead of activating G protein, the arrestin binds, and that essentially prevents the G protein from binding and blocks its signaling. So we discovered that system in the course of looking for how the receptors became desensitized. But then about 15 years ago, we discovered, much to our and everybody else's surprise, that the beta-arrestins themselves were signaling molecules. And that at the very same time they were turning off G proteins, they themselves could serve as signaling molecules, and often to good advantage. On the other hand, sometimes their activation was responsible for certain side effects that we just talked about. So the ability to stimulate the receptors and make them then signal down either the G protein pathway or the arrestin, but not both, in particular circumstances, gave one the ability to often design drugs which would have more selective effects and fewer side effects. And I think the development of such drugs is going to be a big focus over the next decade. Another big focus, I think, is going to be the development of what are called allosteric drugs. So what are allosteric drugs? Well, in general, if you take the family of G protein coupled receptors, essentially all the endogenous ligands and neurotransmitters in our bodies which target these, I'm talking about molecules like so many, but just for examples, adrenaline, dopamine, acetylcholine, serotonin, glucagon, parathyroid, goes on and on and on. They all bind to something we call the orthosteric binding site. So the orthosteric binding site is the site to which the real endogenous ligand for that receptor binds. Orthosteric drugs, either agonists which stimulate a receptor or antagonists which block it, generally have in common that they also bind to the orthosteric site. They're all competitive for the same site. But we're only realizing in recent years that there are many other sites on these receptors to which drugs could bind. We call these allosteric sites. So an allosteric site is any site on a receptor other than the orthosteric site. Now, we don't even know where these sites are. But due to structural work that many labs are doing, X-ray crystal structures, etc., we've done some of this work, we're now finding out exactly where these allosteric sites are. And these allosteric sites provide us with a great deal more real estate in terms of trying to develop drugs. Rather than having to fit them into this one highly conserved orthosteric site, we can now explore sites all over the receptor. And often these drugs have unique and different properties that we haven't seen before. So I think the development of allosteric drugs is going to be another very big direction in the next decade or so.
Thank you very much for that answer. So there are going to be some great breakthroughs in the field, like you said, hopefully.
Mm-hmm.
So I had another question, which is rather like another turn in this discussion. So I wanted to ask you, what's your favorite part of your day as a researcher? What's the favorite part of your day?
Well, it's interesting. Somebody once asked me that question a number of years ago. And the answer I gave, which is still true, is that I have two favorite times of the day. One, when I leave for work in the morning, and two, when I come home at night. When I leave in the morning, I'm filled with a sense of anticipation and expectancy, generally optimism, wondering about, what new things will fall into my lap today? I mean, what experiment will work that I wasn't expecting? What discovery might we make? Etc. Now, of course, most days none of that happens, but it doesn't matter. I go in every morning just anticipating that today might be the day when something really cool is going to happen. But then when it's time to go home, which for me is, maybe around 6:15 or 6:30, I'm also very excited because I enjoy spending my evenings at home with my wife, Lynn, chatting, relaxing, reading. Be honest with you, most evenings I still do a couple of hours of work, either paperwork or whatever, catching up on the literature or writing papers, watch the news. But I very much enjoy that and interacting with our 4 cats. So yeah, I would say for me, the best parts of the day are heading in and heading home.
Probably Bhavana can ask a question now.
Yeah. Everyone has their own story of success. Everyone has their own way of having fun. And, what's your story of becoming a Nobel laureate? And what did it feel like when you, finally got the Nobel Prize? And what were the changes that you felt, the things which you felt that were changing after you got the Nobel Prize?
Well, that's a good question. I guess every Nobel laureate's experience of this is a bit different, but yet there are many things in common. Now, one thing that was somewhat, certainly not unique, but different about my experience is that I won the prize when I was 69 years old. I'm now 78. And people had been telling me for years, Bob, you're going to win the Nobel Prize. Or asking me, Bob, why haven't you won the prize yet? Or when are you going to win the prize? And that just went on and on and on. And then years passed and I didn't win. And, initially I was kind of disappointed because everybody was, sort of hyping me that I would win. It didn't happen. But then in 2012, it did happen. So at one level, I was not amazed that it happened because people have been saying for years, hey, this has got to happen. On the other hand, I really was surprised because for 2 reasons. First of all, there were no rumors or chatter. You might expect, well, if this is coming, somehow somebody would leak it, the word would get to me, nothing. The other was that I won in chemistry and not in medicine. And as you know, the Nobel Prize announcements, which, as you probably know, are coming next week, are made one a day, starting on Monday, and always in the same order. Monday is medicine or physiology, Tuesday's physics, Wednesday's chemistry. Well, so Monday had come and gone, and I hadn't gotten a call, which didn't surprise me after all those years. But then Wednesday at 5 a.m., the phone rings. I didn't hear it because I sleep with hearing aids. But fortunately, my wife did. And so she, in a sense, knew what was going on before I did. Somebody got on the phone and said, this is a call from the Royal Swedish Academy in Stockholm, and may we speak with Professor Lefkowitz? So I was fast asleep. She gave me an elbow in the ribs and said, somebody's calling from the Swedish Academy of Sciences. So I immediately knew what was going on, but I was a little confused. And they immediately told me that I had won the prize in chemistry and that I would share it with Brian Kobilka, who had been a research fellow in my lab in the mid to late 80s. So in that sense, I was also surprised. But it really is a life-changing experience, I can tell you that. First of all, in a sense, it kind of changes your name because whereas I used to be Bob Lefkowitz, now I'm Nobel Laureate Bob Lefkowitz. It doesn't matter where I'm being introduced. It doesn't matter how irrelevant the fact that I'm a Nobel Laureate is to the occasion. I will always be announced as Nobel Laureate. And it's amazing the luster that the prize has after all these years. I mean, the prize has been given out for, I think, 115 or 120 years. but it is by far the most revered and respected prize in the world. And people are often intimidated by the idea of meeting a Nobel laureate. You know, we still put our pants on, what do they say, one leg at a time. But yeah, it's really amazing. People often say to me, I never met a Nobel laureate before, like with some alien form. And you also get invited to speak, you know, about things that you know nothing about, which I'm more than happy to do. But it is kind of funny, some of the invitations that you get. So it really does change your life in many ways. And of course, you become much busier because, and you know, it's really interesting in this sort of virtual age that we're all living through with the COVID pandemic. I'm giving so many more talks than I used to because I don't have to go anywhere. I can sit up here in my study and talk to folks like you or give a lecture. I think in a couple of weeks, in the course of 1 week, I'm speaking at 2 different institutions in Korea. Yeah, just coincidence. There are weeks I give 5 or 6 talks. I might give several in a day, you know, at regions all over the world. Which of course would not be possible if one was traveling. And I've always been kind of travel averse, to be quite honest with you. Like anyone else in my position, I've had to travel a great deal throughout my career. But I've never enjoyed the travel per se, by which I mean the getting there and the coming home. I've seen a lot of interesting places, and that's fun. But I've never been a big one for travel. So yes, it's a life-changing experience, without a doubt.
So, is there anything that you would like to say to 17 or 18-year-old students who are just entering college to study chemistry or say medicine? Because these days, fewer and fewer talented people are like considering going down the academia path nowadays and moving into high-paying jobs or something. So, with most of the talent being extracted out of this field, so do you have anything you'd like to say to students who are just entering college right now?
Yes, I would. I can tell them that as somebody who started out anticipating only a career in medicine and who wound up having a career both in medicine and biomedical research, that I honestly cannot conceive of a more enjoyable, stimulating, and fulfilling career. You have a chance to do something that really matters. And if you look up here over my shoulder, here's well, you can't see it, it's a podcast, but there's a book which I published, my memoir, early this year. It's called A Funny Thing Happened on the Way to Stockholm. You can get it at Amazon or in bookstores, whatever. I think if you read this, you may, and I hope you will, be inspired to see just what it's like to have such a career. In the book, I tell my story, beginning as a little boy, as I said, when I was inspired by my own family physician, all the way through to what turned out in the end. And I illustrate with many different, often humorous stories, which I think you'll enjoy. You do not need to be a scientist or a student of science, I think, to enjoy the book. So I do recommend it.
People are starting to invest in this concept of outrunning death and reverse aging. So what are your thoughts on that?
You're asking what I think about well, I'd love to do some reverse aging myself. No doubt about that. I'm 78 and I have coronary artery disease, that's atherosclerosis, a legacy from both my parents. My father died young, age 63, of his 4th heart attack. And my mother lived to a pretty ripe old age, but she also had coronary artery disease. So I knew I was branded with that early on, genetically, very high cholesterol, etc. And in fact, at age 50, I developed angina and had to have quadruple bypass surgery. But here I am, almost 30 years later, still going strong. I try to take advantage of absolutely every medical advance that comes along in the way of medications, lifestyle modifications. I work out every day for an hour. I take several medications for blood pressure, cholesterol, stress reduction, whatever you can do. I do think that there are developments coming, and there are developments that already have occurred, which offer people the opportunity to live longer and to make the most of, whatever genetic hand they were dealt in the big card game of life that we're all a part of. So I'm actually a big believer in lifestyle and medications, etc., to reduce risk from all manner of chronic diseases, such as heart disease, cancer, degenerative diseases like Alzheimer's and other forms of dementia. But we have so far to go with most of those. Some of the advances in atherosclerotic disease have been more dramatic than some of the others, and I profited from those. The fact that I'm still here, I think, is a real testament to how far some of these treatments have come. But I do love the idea of reverse aging. Certainly in the case of coronary artery disease, there have been a number of reputable studies that have shown that with aggressive enough treatment, you can actually reverse the amount of atherosclerosis in the coronary arteries and other artery beds. So that's a classic example, I guess, of what you're calling reverse aging.
So I also wanted to know your thoughts on another concept that I'm reading about. So what are your thoughts on both the biological aspect and the ethical aspect behind CRISPR technology and genome editing techniques? As in, to what extent their use should be permitted, or the subsequent black market uses that may follow, informed consent, and those sort of problems?
This is a very thorny issue. I mean, obviously, the gene editing strategies and CRISPR that have been developed recently are amongst the most powerful, but at the same time ethically fraught things that have come along. There was this case in China, I guess a year or two ago, where it's already been applied to produce a gene-edited baby who I gather has been fine, although I don't know much about that. But I think it's got to be very tightly regulated because there's just no way to fully predict what off-target effects you may get. And once you have a living human being, if you've screwed it up, what do you do then? So I'll be honest with you. I mean, it's not something that I've thought deeply about, nor is the gene editing field one that I am all that conversant with. But I think you are right to flag it as a very, very important area. And I know bioethicists of all flavors are working on this. You undoubtedly all know the name Jennifer Doudna, who shared the Nobel Prize a year or two ago for developing these CRISPR gene editing methods. So we have a lecture at Duke called the Lefkowitz Lecture. And she was the Lefkowitz lecturer about 3 years ago, something like that. And she participated in some very nice panels that really discussed this. But yeah, it's a fraught issue, to say the least.
And as a follow-up to that question, are there any legislations that you would change to improve how science in your field is done with respect to rules, regulations, or even funding issues?
Not so much funding issues, but I'm increasingly frustrated by all the regulations that just keep being piled on, layer after layer after layer. We are regulated. Everything we do, every experiment has to be justified. The regulations in particular with respect to care and experimentation on animals just seem to get more and more onerous, and grants, manuscripts that we submit for publication, again, regulation at every level, which just, I think, really puts a brake on scientific progress. And I'm really sorry, because I think it's a slippery slope and it just keeps getting worse and worse and worse. So too much regulation as far as I'm concerned.
Lukas, is there anything you'd like to ask?
Yeah. Another thing I wanted to ask is, you've worked with many worldwide known scientists. Many of them are women. What do you think about women in STEM fields, and how can we increase the number of women in STEM fields?
I think we're definitely heading in the right direction. There's no doubt in my mind. When I went to medical school, for example, class of 1966 at Columbia Medical School, there were 112 students, and there were 8 women. 4 years before, in 1962, I just happen to know these figures because I looked them up, there were also 112, and there were, instead of 8 women, there were 4 women. Okay. And who knows? I mean, if you go back into the 50s, there may have been no women at all. Today, at the Duke Medical School, as well as virtually every medical school in the United States, it's about 50-50, but Duke, like most schools, is something like 56 or 57% women. So there's actually a slight preponderance of women. We have talked for years about the glass ceiling for women in science and medicine. But the fact is, if I just take my institution as an example, at Duke, the dean is a woman. The previous dean was a woman. We've had a female president in recent years. The provost of the university is a woman. About half the chairs of the basic science departments in our medical school are women. The chair of psychiatry, medicine, I don't know what others, are all women. So I think we're really making progress. And the National Academy of Sciences, when I was elected many, many years ago in 1988, had very, very few women. Now there are many, many women. So I think that there really has been progress, and it's not been any accident. I think many institutions have programs in diversity, so that I think that we're really, as I say, things are, now again, I'm not a female, so I don't know what it feels like, to be on the other side of that gender divide. Never have been, obviously. But, and, I've always been kind of gender blind. I never have considered, gender when I've been hiring. Maybe I should more than I have. But in general, I have about a pretty, I don't try to keep it at any level, but it's probably close to 50-50. It may be, might be 60-40, etc. Just because there are more men who apply for positions. But yeah, really heading on the right track. That's my feeling.
Thank you for the nice answer. Kushal, I think you wanted to ask something.
Nothing.
So, is there something that you like to do when you aren't working on research or medicine, something non-academic?
Yeah, there are two things. Alas, I've never developed a hobby. I regret that. If I ever retire, which is hard for me to imagine, probably be nice to have a hobby. I don't play golf. I don't collect stamps, anything like that. Two of my leisure time activities, which I very much enjoy, are reading. That's the major one. If we were downstairs, I would turn my computer around and show you my night table. There are like 8 or 9 books piled up there. all manner of things. I mean, you just can't imagine the variety of subjects. Most are nonfiction. I just don't read a lot of novels. Every once in a while, it's interesting. My wife reads almost exclusively fiction. I read almost exclusively nonfiction. Every once in a while, she'll say, "You got to read this novel," and I'll do it. But so reading all kinds of things in fields that would probably surprise you. I mean, that have no relation to anything that I really do. The other, which has been a can't really call it a passion, but something that I've been very interested in, and it relates to, we talked about reverse aging. I very much believe in the salutary effects and importance of regular exercise. And so for many, many years, I was a very serious jogger. I deliberately don't use the term runner because to me that implies a level of talent that I never had. But I was a jogger for, oh my God, starting at age 25, maybe till about age 65, so at least 40 years, jogged tens of thousands of miles. But then various orthopedic things, plantar fasciitis, whatever, drove me off the roads. So about 20 years ago, I began equipping my basement in my home as basically as a gym. And I would say that in terms of quality, I'd put it up against any little exercise club. So I've got 4 different aerobic machines in a huge unfinished basement with a big widescreen TV. And I work out there for close to an hour every morning, using different ones depending on my mood. These days, mostly the elliptical, but sometimes the treadmill. But I also have an upright bike, a recumbent bike. Then in a separate room, I have a universal gym with 2 different weight stacks and many different positions. 2 people can actually work out there simultaneously. I do that only 2 or 3 days a week. So I'm really very, very regular in my exercise. So I would say reading widely and exercise are probably my 2 major leisure pursuits.
Thank you, sir. So the next question is there anything you have to say to the new generation of biochemistry students, like what of inspiration to them?
Well, as I said before, I cannot imagine a more gratifying career than one in either medicine or science, or in my case, both, because it's so fulfilling. I think what you want to look for in your career is something which, first of all, that you're genuinely interested in, better yet, passionate about, but at least really interested in. 2, something that you have some talent for, okay, some proclivity for. You don't have to be the best in the world at it. But for example, let's say you've always struggled with math, okay? It's probably not a good choice to decide you want to be an astrophysicist, okay? That's not going to turn out well. You need something which you're interested in, but you have a proclivity or a facility with. And then I think if you stick with those 2 things, you can wind up doing something for your career that you really enjoy. I mean, I consider myself part of a, unfortunately, relatively small group of people in that I've never, ever considered what I did work. So I don't really look at what I do as my work. It's just sort of what I do. Okay, I mean, it's like an artist paints. Very few artists, I think of their job as being a painter. They're a painter. That's what they do. That's how they express themselves. And that's always been the case for me with the laboratory.
Thank you very much, sir. Sir, our last question is that, do you have anything to say about our initiative, the Aurora Academic Journal?
Give me that again. I had trouble with that.
Okay. So, do you have anything to say about our new initiative, the Aurora Academic Journal?
Still not getting it. I heard initiated or.
Do you have anything to say about our new initiative, the Aurora Academic Journal?
I'm sorry. How about Lukas? You get the last shot at it, maybe. Can you try it?
Okay. The question was if you have anything to say about our initiative, the Aurora Academic Journal. Like, yeah.
Ah, now I get it. Well, I wish I knew more about it, to tell you the truth. I still don't know too much about it. But if it has to do with young people who are interested in STEM and who are trying to get others interested in it, I couldn't be more supportive. I think it's great. I think it's absolutely great. You folks are at what level? Are you college students or grad students or high school students? What are you?
High school. Most of us are high school, and some of us are currently enrolled in the universities.
Okay. And what country or countries are you in?
So I'm from India.
India? How about you, Kushal?
I'm from India as well, but I'll probably be doing college abroad in the
Okay.
US or the UK.
And Lukas?
I'm actually from Austria.
Okay. And Bhavana?
I'm from India.
Okay. So most from India, one from Austria. How big is your operation? How many students are involved with you?
So currently we have 50 plus members from about 20 countries.
How many countries?
20.
Wonderful. Well, you have my full endorsement, and hopefully this podcast we've been doing for the last hour or so will help to attract some attention to your cause.
Yes, sir. Sure, sir.
Thank you very much.
Okay, it's been a pleasure, and good luck to you all.
Yes, sir. It was an honor for us to have met
It
you.
is a pleasure to meet you, sir.
My pleasure indeed. Good luck.